Hello everyone, welcome to Pepcoding. So in this video, we are going to start the next question of our binary tree series. So the name of the question that we have this time is vertical order traversal of a binary tree. Okay, let us see what is this vertical order traversal. And in this question, we'll be given a tree. Okay, a binary tree will be given to us, and what we have to do, we have to print the vertical order of it. So before telling you what is the vertical order, I want to tell you something about this node and the child relation. Something, suppose it is a node that is a, and here we have, we make it a little bit this side. Suppose that is a node A, we have a node B and a C. Okay, so the angle that this node subtend with these two childs is 45. Okay, this is 45 and this is also 45. So this will make a child here, this will make a child here. So this is 45. I mean, this is 45. This will be suppose E, this is F. Okay, so this is G, this is H. So what will happen is, as this is also 45 45 and this is also 45 45, so this A and this FG, this A and this FG both will lie in the same vertical line, but the difference is this F and G will be like this will be one after the other. Okay, like one behind the F behind the G or G behind the F, it would be like this. Okay, so so it means that I'm telling you that these two are on the same vertical level. Okay, are on the same vertical line. So this is what I need to tell you. So let me introduce you to the vertical traversal or the vertical order of a binary tree. So what is this vertical order? So let us see. So in vertical order, what we need to print is, we need to print the vertical order that is like this. This is a vertical line, this is another vertical line. Okay, this is also in this vertical line, and I will make it like this. This is in a vertical line, this is a vertical order, this is a vertical order, these three are in the same vertical line, this is a vertical line, and this is a vertical line. Okay, so output would be like, my output would be like, see, my output would be like, let me, okay, let us write from this only. But before that, I want to make a copy. Before that, I want to make a copy of it so that I will not lose it. Okay, so yeah, let's start. We were at this, right? 1, then 2, then third vertical level, fourth vertical level, fifth vertical level, then sixth vertical level. So output will be printed in such a way that first level will say that I have 30, second will say I have 20, 5 and 2. Okay, this order matters, this vertical order matters, that one which is coming first in the vertical line will be in the first. Okay, will come first, and then in the third we have 10, then 40 60 are on the same vertical line. So what will be the order? It doesn't matter for them, as both are in the same horizontal order or in the same vertical order, right? So these are in the same vertical level. If we'll say it is level 1, it is level 2, so both are in level 2. So what would be the order for them? Order doesn't matter for them, only vertical order matters. So now 5 5, that means 4. Okay, now for this it will be 50, then 10, and then 8. Okay, and then for this it is 70. So what is it? It is 70, and then for 7 it is only 7. Okay, so it would be like this. So we need to think that how we can do this. So some people will say that you can achieve it with the help of recursion, and but how? Because you need to traverse it, you need to print the traversal, right? You need to print the order. So for that you can use recursion. But how you can use the recursion? You need to think that. So let us say that we need to store the vertical order, right? We need to store the vertical order. So what we will do, we will traverse in it by using some data structure like hash map. Okay, we'll make a hash map or we can say ordered map. Okay, basically I'm saying that we will take a map. We'll take a map, and what we will do in it, what we'll do in it, in that map, in that hash map or unordered map, what we will do, we will simply make a key of integer, and we'll make a list in which we are going to store our order. Okay, I'm saying this would be the format. This would be the format in which I'll be storing some our data, that is the vertical data I'll be printing in this order. Okay, but I maintained a key that is integer. Okay, and that integer will be level. Okay, so I'll start from 0 level. Here for me it is 0 level, and when I'll go to my left, then it will be my -1 level. When I'll go to my left, then it will be my -2 level. Okay, that is, after going to left I'll -1, and after coming to right I'll do +1. Okay, for left -1, for right +1. So this would be the idea. So let us traverse into this with the help of recursion. So what I'll do, first of all, this is my 0th level, right? So at 0th level I'll print I have 10. Then I'll go to -1. Okay, and at -1 I'll say I have 20, and then I'll go to -2, and then at -2 I'll say I have 30. And also I'll maintain a min and max, min level and max level. Okay, min level and max level. So min level is initially 0 and max level is also initially 0, but right now min level is -2. Right, min level is -2 and max level is 0. Okay, so now we'll go back to this. So here my level was -1, right? So I'll come to right. So when I come to right, I'll do +1. So -1 +1, that is 0. It is at the 0 level, so 0 level we made 40. Okay, now we'll go back to this. This will come back to this, and this will go to this again at 0 level. So from 0 we'll go to 50. 50 is at level 1, so max will be 1. Okay, so at 1 level we will print we have 50. Okay, and then we'll come to this. So as I'm coming left, I'll do -1. So 1 -1, that is 0. At 0 I have 60. 60 at 0, and then again -1. At -1 I have I have 5. Okay, I have 5. Then again I'll come to this, and then I'll go to right. So it was -1, it was 0. So from 0 plus 1, that is at 1 we have 10. At 1 we have 10. So we'll go back to this, and then go back to this and this. This was 1, right? This was 1, and it is +1. It is +1, that is 2. At 2 we have 70. So it is also updated. It is 2. Now we'll come to left. When we will come to left, we will do -1. That is, at 1 we have 8. At 1 we have 8. And at 4 we have, at 1 we have 8. I'll do again -1. At 0 we have 4. At 0 we have 4. I'll do again -1. At -1 we have 2. At -1 we have 2. Then I'll come to this. Here it was -1. It is 0. Then it is 1. It is 2. Right? And then we are going to right. When we are going to right, we'll do +1. 3. So max level is equals to 3 now. So at 3 I'll have 7. 3 I'll have 7, and this is how I'll traverse my whole tree. So is it matching my answer? Let us see. Let's see, is it matching my answer? Let us take this to upside. So here it is. See, is it matching the order? Let us see. We have 30 in level 1. So here, as we are making the level from 0, then -1, then -2. So -2 is the min level, right? So at -2 it should be 30, right? Because my first level is -2. So at -2 it is 30. At 2 it is 25 2. At 2 it is, at 2 that means 2 means -2 plus 2, that is 0 plus 1 at one level, so that is this, where is it, at minus 1 level, right? At minus 1 level, basically it is basically it is minus 2, then it is minus 1, it is 0, then 1, then 2, and then 3. Okay, because our level is increasing in this way. Okay, so we don't have to print this, we just have to maintain a list where we can store our vertical traversal. Okay, where we can store our vertical traversal. So let us see that if the vertical traversal is matching or not. Okay, so at minus 1 it should be 25 2, at minus 1 25 2. Okay, done, it is correct, it is correct. At 0 it is 10 40 64, 0 10 40 64. Okay, correct, no issues. At 1 it is 50 10 and 8, at 1 it is 50 10 8, correct. At 2 it is 70, at 2 it is 70, at 6 it is 7, that is at 3 it is 7. Yes, it is. So it is giving me the right order, it is also right, it is also right, so it is giving me the completely right order. So why am I saying that we cannot do it with the help of recursion? Why am I saying that? People will say you can do it with the help of recursion, but still by maintaining some data structures also we cannot do it with the help of recursion. Why I'm saying this? So let us have a look into it. So let me take one more example which will help you in making it clear that we cannot do it with the help of recursion. So let us take an example, and that example would be suppose node like suppose 10, then 5, then 4, then 3, 2, 5, 9, 6, 4. Okay, suppose like this. So it should be, the answer should be, if I write the answer, then it should be, this is the first, the second level. Okay, both will come in the second level, that means these two, then this, then this, and then this, right? So order should be where's the pen? So at 0, I mean at first level we have, or we can say at 0 level we have 5 only. At 1 we have 10 4 and 2, order doesn't matter for these two. And then at 2 we have 3 5, at 3 we have 4 9, at 4 we have 6. Okay, so let us see if it is matching or not, if the order is matching or not. Let us see that. So how we can do it? So we are going to traverse into it, right? So let me first of all take it out from it, and we will put it here. Okay, we will check it after some time. Let us traverse and store it. It is at 0, right? So at 0, take some other color. So at 0 we have 10. Okay, so I'm going at minus 1. So at minus 1 I visited 5, I stored it, I came to this, then I coming to right. I'm coming to right. When I'm coming to right, I'll write at 0 again. I visit at 0 again. Yeah, at 0 again I visit 4, and then coming to right, that means plus 1. At 1 I'm visiting 5, at 1 I'm visiting 5, then at 2 I'm visiting 9, then at 3 I'm visiting 6. Okay, and then going back, this, yeah, at this, here it is 1. At 1 I'm visiting now 3, at 1 I'm visiting 3, and then coming to this, it is 1 and then minus 1. That means at 0 I'm visiting 2, at 0 I'm visiting 2. Okay, no issues. And then at this, it was 1 and it is 2, right? 2. So plus 1, that means it is 2 now. At level 2 we'll visit 4. So this is the order for it. So let us match the order. Is it matching our required output? Let us put this one in here and let's put this thing here. So okay, so let us see that is it matching our order or not. So basically it was 0 minus 1, right? So at let us find first of all minus 1. Minus 1 means at 0. Minus 1 is 5. Okay, correct. Okay, no issues here. Then at 1, then after this 0, right? Minus 1 and then after this 0, that means at 1. At 1 we have 1042, 1042, no issues, correct. Then at 153, at 153 means it is, if it is 0 1 then 2. At 2 we have 53, we have 53 but it is 35, so mark it. 2, let us see at 2. So at 2 we want 94, right? At 2, no, it is the original order, right? It is the original order. At 2, that means it was 0 1 2 3. At 3 we want 4. At 3 we want 4 9, but actually we are getting 9 4, right? With the, it is the green one is what I wrote with the help of recursion, but this blue one is the original answer. So original answer is somewhere different, right? The order is different. So 3 5 is now 5 3, and see, it is not the horizontal order, it is the vertical order only. See, 3 5, it should be 3 5, but it is 5 3. Okay, it is wrong. Then this is right, 4 to 6. Okay, at 4 we have 6, this is right, but these two are wrong. So why it is wrong? We know that recursion travels in a depth. Recursion travels in a depth, and when it got that it has some nodes in only one side, that is right. So it went to the depth of the right, and it printed the nodes which is coming, the nodes which are coming in the depth first are printed first. That means 9 came in the depth first, right? So 9 is printed first, but what we need this order. We need this should be printed first, then this, then this, then this, then this. So do you know any traversal? Do you know any traversal which increases in this way? In this way, is it a radial increment? I'm saying yes, it is a radial increment. So do you know any uh method or any technique in which we increases radially? Do you know any method? I will say that I have read a method that is called BFS, breadth first traversal. So I'm going to use that breadth first traversal in that, because breadth first traversal increases radially, which will help me in increasing in a way in which I want, right? I want to increase in a radial way, in a horizontal way. So I'll take the help of BFS. So let us see how we can do this with the help of BFS. Okay, so let me take original tree. Okay, going to maintain the same thing. Okay, the same map will be needed. So we will maintain the same thing, map of integer versus list of integer. Okay, in which we will store our list of vertical order. Okay, and other thing that we need a queue, right? We need a queue for this BFS. So what we'll do, let us maintain a queue, and suppose it will be our queue. Our queue will look like this. So what we are going to do into this? So what we'll do, simply I'll put two things in my queue. I'll make a pair. And let me tell you. Yeah. I'll make a pair and I'll push a node. And second thing is its level, horizontal level. Okay. I'll push a node and its horizontal level, and for going to left I'll do -1. For right, when I'm adding the right child, I'll do +1. Okay, so this is what I'll do. Let us see how I can do that, and is it giving me the right order or not. So let us see. So first of all, I'll add 10 with 0. Okay, I'll add 10 with 0. So after this I'll calculate the size, as I want to do the work for each level, right? So size is, so let us say s is 1, right? So s is 1. I'll run a loop one time, and I'll say remove it. Okay, remove it, add it. So at 0, I'll add it to my map. So at 0 I'll add 10, right? At 0 I'll add 10, and then I'll add its left and right child. So when I'll add its left child, it will be 20 and with -1, and then 50 with 1. Okay, so these two will be added. So what I'll do, again calculate the size and do the work for this size. So size is 2 now, so do the work for first one, remove it, and then at -1, say we have 20. Okay, store it, and then at 1 we have 50. So again, after removing, add its child, right? It is 20 is removed, so add its child. So it will add its left child. So 30 will be added with -2, and 40 will be added with 0. Be added with 0. So what we'll do, we will simply remove it, and then added it to our list, and then again added its children, and then we will do same thing for next one. That means here it is 1 and now it is 0, right? Size is 0. And now what we'll do, we'll simply at level 1 add 50. Okay, we'll add 50, and then what we need after adding 50, we will add its children's. So that is 60 and 70. So for adding 60, I will do what is the level of 50, that is 1. So -1, that means 0. And for 70, its level was 1. So right, that means +1, that means 2. Okay, so these two will be there. So now we'll calculate the size now. The size is 4. So we'll do the work 4 times. Okay, we'll do the work 4 times. That means at -2, we have 30. Remove it and add it, and then add its children. So for 30, we have, where is 30? Okay, 30 does not have any children, so go to 40. Okay, so remove it at 20, at 0, add 40, and then what we will do, we will add its children. It does not have any children, so now move forward. So moving forward means at 60, so remove 60. Okay, so let me first of all erase this, not this, till this. Okay, so it should be like after 10. Okay, after 10 we have what is added, 40 is added, right? And 60 is already added. At 0 we have 60, so we have not added it, right? At 0 we have 60, so added 60, add its children, so children should be added. So we'll add its children. So its children would be it is 0, right? So at -1, so 5 comma 5 -1 will be added as a pair. Okay, and then as the right child, 10 will be added, and as 60 has 0th level, so it would be 1, right? Because right will do +1. And then similarly it is work is done for this, right? 60, and 60 is already printed, so and also it is removed. So it is removed, added its children. Okay, now so let me write it. What we are doing, remove it, and then print it, and then add children's. Okay, add children's, remove, print, add. So remove, then print means at this, at 2 print. Do we have 2? No, we don't have. So at 2 we should print 70. So printed 70, and then add its children. So we have 8 with level, the level of this -1, yani ki, that means ki 2 minus 1, that is 1. Okay, so this. Now for this it will be 7, right? And level will be +1, that means 2 + 1, 3. Okay, it would look like this. And then and then let us erase these three. 70 is being removed, right? 70 is being removed and also return. Okay, so let us take it to bit this side. So now how it will look like? It will look like this, right? So we need to remove, okay, we need to, yes, we need to calculate now the size is 4, right? So 4 times we'll do it. The size is 4 here, so 4 times we'll do it. Okay, so let us do 4 times. So what we'll do, remove it, remove 5, add it to -1, so add 5. Okay, and then add its children. So where is 5? 5 does not have any children. Okay, so go to 10. So remove 10 and then add 1 at 10. Okay, at 1 I added 10 and then I added its children, but it does not have any children, so nothing will be added. Now remove 8. So 8 will be removed and then it will add its children, that is 4 will be added as it is the left children, so it will add with 0, right? 8 has 1, right? 8 has level 1, so this level minus 1, so that is 0. So now after this we have 7, right? We have 7 and we did the already did the work 3 times, that is only 1 is remaining. So after this is the last work. So now for 7 what we'll do, we'll simply at 3 print 7. At 3 we have 3, no we don't have. At 3 we have 7. At 3 we have 7, right? At 3 we have 7, we print it, and its children, it does not have any children. Okay, so work is done for these 4. So here we are on this level, right? We have only one person here, so we'll remove it. Okay, find its place, that is 0, go to 0, print it, and then we will add its children. So its children is left children, that means we'll add 2 with level -1. So with the level -1, so what I'll do, but I will remove it and then print it, that is 2 at -1, and then simply what I will do, after this at -2 I printed it, and then adding its children is null, so nothing will be added. Okay, so this is how it will work. Okay, so this is how it will work. And anything else that we need to see? Yeah, we need to match if the order is matching or not. Okay, so let us see if we have the answer of it. Do we have the order? I think this is the order, right? This is the order, so let us match it. Let us take this. So this is what we have, and let us match it with the level that we have. So in a level we have 30 only, so 30. Okay, and then suppose our level is starting from this, what we can say, -2, right? So it will be -2, then -1, 0, 1, 2, 3. Okay, so at -1 we have 25 2, at -1 we have 25 2, at 0 we have 10 40 64, 10 40 64, correct. At 4 we have, where 4 means 1, at 1 we have 50 10 8, 50 10, and where is 8, where is 8, where is 8? 8 is removed here, right? 8 is removed here, but 8 is not added, and 8 should be at 1 level, right? 8 should be at level 1. That means this 8 should be at level 1. This means this, I might have not done it, but we can see here 8 is at level 1, so we can write it easily. Okay, no issues. Let us see again. So at 1 we have 50 10 8, at 2 we have 30, at 2 we have 30, that means this, I mean 70. At 2 we have 70, at 2 we have 70, at 3 we have 7, at 3 we have 7. So correct order. So correct order, we are getting the correct order with the help of DFS, and it will not give us the issue that you are going in the extreme depth. You are going into the extreme depth and you are printing the depth order first. So order is also maintained, we know that how to do it. Okay, we are maintaining some map, we are using the depth first traversal, which I mean the BFS, which we have already studied. So let us go to the code directly. Okay, now I hope that you can do the code for it. So now we can easily approach for the code. Let us go to, okay, so let us look into the code of it. Okay, so we are going to code into the Java and code in Java. And so what we need to do, we need to return the array list of integer, right? So what we can do, we are going to use BFS, right? So for BFS we need a queue first of all. So we will make a queue. So queue queue of, make a pair. Okay, queue of pair, queue is equals to new linked list. Okay, with the help of linked list we'll make it, and let us make this class pair. Static class pair. We need a level in it, horizontal level, and we need a tree node of node. And then what we'll do, pair int hl comma tree node of node, right? So this dot node is equals to node, this dot node is equals to node, and this dot hl is equals to hl. Okay, so this is done. And what we need, okay, we need to return array list of integer, right? So what we'll do, array list of integer answer is equals to new array list. Okay, so this is what we will do. Okay, and then array list of integer, and then what we can do, we can add a pair. Okay, we also need a hash map, right? So hash map of integer and array list, right? So integer and array list of integer. Okay, so the name will be map is equals to new hash map, and after this we can add q dot add, we can add a pair. So q dot add new pair. So the new pair will be root and 0, right? Root and 0. So root comma 0, this will be added in the pair. And then after that we will run a loop while my q dot size is greater than 0. Okay, and other thing is we need a minl and a maxl. So what we can do, int size is equals to q dot size. Okay, we will process for one level first. Okay, we will process level by level. Okay, so we are doing work for every level. So I'm here calculating the size so that I can do work for only those elements which are present at the at that level, at that instance. Okay, so I'll say while size minus is greater than 0. Okay, and after this what I'm gonna do, first of all remove, right? So pair rem is equals to q dot remove. So this will give you the removed pair. Okay, now maintain your maxl and minl. So maxl is equals to mat dot max of maxl comma rem dot hl, and minl is equals to mat dot min of minl comma rem dot hl. Okay, so this is what it will give. And after that you need to add this to your array, to your hash map, right? So but before that you need to do new to this array list. You need to, you just have Define this, you have not initialized it. So how you can initialize it? In the beginning only you need to initialize it. So you will do map dot put if absent, map dot put if absent. Otherwise you can also do one thing, that is contains. If map dot contains this, then don't do anything. If map does not contains this, then do new first of all. Okay, if map dot put if absent, directly we will do. So what we will do, rem.hl, if this is not present, then simply do new array list. Okay, simply do new array list, and after this map.get at rem.hl, and at rem.hl you should add what, rem.node.well, right? You should do this, and after that you need to add your children. So what you will do, if rem dot node dot left is not equals to null, then it means that you should add them. And same thing for right, if rem dot node dot right is not null, then you should add them. So dot right is not null, then you should add them. So not null, then that means q dot add new pair, and in that pair you should add node dot rem dot node dot left, comma rem dot hl minus 1. Okay, for left side do -1, and for right side +1, right? So same thing for right +1, just this. Okay, and after this what you should do, okay, I hope it is done. We have maintained our max and min-l, remove, okay, and then add it to your hash map. Okay, I mean the array list. You have array list now, and you are also preparing for the next level. So that is done. Okay, I hope it is done. And after this you will have your min-l, max-l, you will have your array list of integer, but you have to return array list of integer. Okay, that is this answer you have to return. So what you can do is you can run a loop for int I is equals to 0 and I is less than equals to, not 0, it is min-l. Okay, less than equals to max-l I plus plus, and simply answer dot add, what you should add, answer dot add map dot get at I. Okay, and then simply return answer. Okay, and then let us give it a run. So this one is called shallow copy. Okay, the thing that I did in the last, this thing is called shallow copy, because I just have pointed my answer ls to that array list which is inside the hash map. So let us see some error which we are facing. Cannot be converted to int. Okay, so it is root and int, so node int, but I have written int node, so I need to change it. I need to change the order, right? Here it is also, it is root and int, but so here we'll change it. Here we'll write node, and then in the last we'll write int hl. Okay, so I hope this will resolve our error. Let us give it a submit again. Code is running. Let us give it a final submit for all the test cases. So the code is accepted. So I hope that you got this code completely. Okay, and after this we'll meet in the next video with another approach of the same question. Okay, so till then, goodbye, take care.